Hello, everyone. Can you guys hear me? Good. Okay, so I suppose everybody already saw the online video. Did you do that? Okay, good. So let's go over a little bit about alternating series. Okay, so on Tuesday, okay, Tuesday's material is focused on the alternating series. Okay, so alternating series is formed like -1 to the n of un, going from 1 to infinity. Okay, this is called alternating series because un is bigger than 0. So how to justify this one converge? We need 3 conditions. Number 1, 2, and 3. The first one is un bigger than 0. Okay, this condition actually is guaranteeing it's alternating. Okay, if it's bigger than 0, then the series, okay, will be positive, negative, so it's called alternating. Number 2, un should be decreased. And number 3, un's go to 0. Okay, as long as these 3 conditions are satisfied, then that is converge. Okay, so this is all so-called alternating series tests. Alternating series test. Okay, so to get more idea, so let's do some examples. So I will take some examples from the book. Okay. Okay, how about this one? Okay, so -1 to the n plus 1 and 1 over natural log of n. Okay, so justify this one converter that works. So first, is that alternating series? Which means first condition, un positive. Yes or no? Yes. Okay, because un is 1 over natural log of n, right? 1 over natural log of n positive. Okay, number 2. Is that un decreasing? That decrease? 1 over natural log of 2, 1 over natural log of 3, 1 over natural log of 4, 1 over natural log of 5. So that's decreasing, right? And the reason is it is decreasing. The reason is natural log of x is, fill in the blank, is what? It's increasing function. Good, very great. It's increasing function. Okay, natural log of x is increasing function, but we put 1 over of it, so it become a decreasing function. Okay. Number 3, is that 1 over natural log of n? Is that un go to 0? This is very, very obvious, right? Let's go to 0. Yes. Okay, so 3 conditions are both satisfied. Good, 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 Okay, so this one, converge. Okay. Is that clear? Any confusions? You guys are not frozen, right? No confusion, right? Okay. Okay, now I'm gonna ask some further question. Okay, this series is converged, okay? Now, my further question is, same theories, 1 over natural log of n. Okay, is that absolute converge? Okay, my question is that absolute converge? Is that absolute converge? Okay, and no. Okay, someone told me no, then why? Okay, so let's look at this. Absolute converge, we know its meaning, right? Its meaning means this one converge, right? This one converge means absolute converge. So for this one, okay, we put absolute value for everything, and it will be 1 over natural log of n, right? Okay, so 1 over natural log of n, converge or diverge? And why? Any idea? Okay, someone say converge. Any different opinion? Yeah, converge, diverge is just two. It's just two conclusion, right? But why? Okay, how to justify that? How to justify this one? Converge or diverge? What kind of test? Okay, good suggestion. Integral test. Let me see if that works or not. So by integral test, I'm not sure. I'm not sure that works or not. Okay, let's just try. Just try that. Okay, just try it. Okay, so this one is comparable to 1 over natural log of x dx, right? From 2 to infinity, right? Okay, and tell me how to do the integral. Hmm? Good. It's 1 over x. Okay, I see your mistake. I understand your mistake. Yeah, okay. That's a good mistake. Okay, how to find it? Natural log of inverse. Then chain rule. Then why you're gonna need chain rule for that? I'm confused. Why do you want to use chain rule? How to find the integral? What does that mean, chain rule? Oh, you want the integration by parts? Okay, I follow you. So, yes, and then what happened? What happened? -1. Are you trying to take a derivative? It sounds like a derivative. Okay, I'm confused why you're going to take a derivative for that. Okay. Yeah, we need the integral. We do not need a derivative. That's not easy, right? Find the integral for this guy is not easy. Not easy. Okay, we want to do integral tests because we want to take some easy stuff, but that's not easy. So can we try different tests? Or we still just focusing on how to find the integral? Okay, I will suggest different tests. Integral test, at least for me, that's not easy. So let's just do not consider that. Okay, can we do some other tests? Limit test. Limit test. I have never known what is limit test. What is limit test? I have never heard about that. I heard about limit comparison test. Okay. So limit comparison test. So which one you want to compare? So which one you're going to compare? If you want to do limit comparison, you have to compare with something. How do you compare? Any suggestion? One over natural log of x minus one. I have to say, yeah, it is comparable. Yes. It is comparable, right? These two things, because natural log of n go to infinity, so it's minus one doesn't matter for anything. And but then, yeah, that's not seem easier. It's actually make it more difficult. Ratio test. Okay, someone say ratio test. Let's do that. So ratio is going to be 1 over natural log of n plus 1, right? Natural log of n, right? So this is ln over ln plus 1. And then what's the limit? What's the limit? Okay. Matthew said 0 and 1. Which one is your answer? You can give me two answers. Which one? 1. So what 1 means? What 1 means? What does 1 mean? If you get a limit, if you get a ratio, yeah, inconclusive. Inconclusive means you need more work. You need more work. So that also means ratio test fails for this guy. So ratio test also fails. Okay, so okay, let me see. Okay, looks like nobody have good suggestions. So let me suggest you to do something. Okay, ratio test fails. Limited comparison test fails, and integral test fails. Can I do comparison test? I want to compare 1 over natural log n with somebody else directly. So which one I should compare? This is my hint. It works, but tell me, okay, tell me, if I want to do comparison test, which series I want to compare? Yes, 1 over n. Very great. Okay, so which one is bigger? Okay, if you think the 1 over is annoying, so let's see which one is bigger for these two guys. Okay, first, okay, these two guys, natural log of n and n, which one is bigger? Okay, so n, right? Because you can think it in this way. Okay, natural log of e to the 2000 and e to the 2000. This guy only equals to like what, 2000? But this guy is extremely huge, right? Okay. So this is definitely true for lesson, okay? If this is true, then we put a 1 over, okay, 1 over. So which one is bigger? The left, right? The left or the right? Left. Okay, so this is true for everything, right? This is true for everything. So I'm going to take a summation. That still works, right? You agree? Now let's tell me, what's this? What's the one in the circle? Harmonic series. So where it goes? Infinity. So this one is bigger than infinity. So where it goes? Infinity and diverge, right? Is that clear? Does this make sense? Good. So, okay. So what's the conclusion for the original series? Is that absolutely converge? Right. It's not absolutely converge. Okay. It is not absolutely, because this one diverge. So this original series converge, but not absolutely converge. And that's the conclusion, right? Okay. It's converge because we apply alternating series test. Okay, but if you put absolute value, okay, we find it's diverge. This is a very interesting series, right? How do I know that? Because I have such kind of feeling, I think. You know, how how did I study the calculus in when I was undergraduate? You couldn't imagine that. You know, for me, and because my major is math, so my classmate, you know, in China we have a class, so we study all the courses together, and my class is about 30 students, and almost half of the class, yeah, we have like we have done more than 10,000 questions of calculus. This is 100,000, sorry. Yeah, we have done so many exercises, so we get this feeling by large amount of practice. That's what we did. It's not like you guys, it's just like do a couple examples and you feel, oh, I'm satisfied. No, math major is not like that. We have done large amount of questions. We have to. That's the reason I got the feeling. Why I see this one, 1 over natural log of n, I know it must be comparable to 1 over n. Okay. You will get the same kind of feeling after you've done a large amount of questions. I believe so. Does this make sense? And sometimes, okay, even though you do not have such kind of feeling, but at least, okay, you can try that. Okay, you can, just like we did this exactly the same question. Okay, we have tried ratio test, we have tried integral test. Everything fails. Okay, I just take a look about natural log of n. Okay, and I find, okay, natural log of n is big. It's very big. Bigger than what? Bigger than 1 over n. So, okay, so just keep trying. Okay, because you don't know which one works. Just keep trying. You know how many times, how many times Edison fails when he want to generate the light bulb? I was told it 1,000 times, right? So just keep trying. Does this make sense? There's no any response. It looks like, it seems that everybody got frozen. Did you guys frozen? Okay. Okay. All right. You know, if you guys have no any response, I just thought about my internet has problem. Okay, I see a very good example. Let's just try one more, and then we keep going. Okay, so n from 1 to infinity, -1 to the n plus 1, so n factorial over 2 to the n. Okay, so how do we justify this one? And for this one, I will never give you any hint. Okay, you do that by yourself, and you tell me how to do that. Okay, so how we can solve this problem? No, my question is find converge or diverge, not absolutely converge or diverge. Okay, find converge or diverge. Okay, so ratio test is a good suggestion. Let's try that. Okay. Yeah, why not trying? Just keep trying. I just said, okay, keep trying. Let's do that. So absolute value of an plus 1 over an, right? This is equals to, okay, -1 to the Yeah, that's another good suggestion. But okay, someone suggests to do ratio tests. So let's do one by one. Okay, let's keep trying. Okay, after I finish ratio test, I will do the three conditions. Okay, alternating series test. All right, let's just do one by one. Okay, let's focus on ratio test first because that's the first suggestion. So how to do ratio test? We need to find the ratio of an plus 1 over an. Okay, and then for an plus 1, that's going to be a negative 1 to the n plus 2, n plus 1 to the factorial. Two to the n plus 1 over negative 1 to the n plus 1, n factorial, 2 to the n, right? Okay, so this is equals to, we don't care about the negative sign because that's absolute value, right? It's always positive. So this one can be canceled because absolute value. Okay, and this is equals to n plus 1 factorial over n factorial, 2 to the n over 2 to the n plus 1. Okay, is that clear so far? Okay, so this is equals to limit. So now let's do some cancellation. Okay, now you tell me what's this after cancellation? Yeah, 1 over 2. Okay, what's this after cancellation? N plus 1. Okay, now where this one goes? Infinity. This one goes to infinity. So then what happens to the original series? It's not absolute converge, right? Ratio goes to infinity, so it's not absolute converge. Now what's our conclusion? This one is not absolutely converge. Means this one what? Yeah, diverge. Someone said diverge. Now I'm asking the reason. If you have a series AN, remember when we studied absolute convergence? We said, okay, if this one converge, then this one converge. Do you remember that? Okay, now, okay, but our statement for this particular example is not saying that, it's not in that way. For this example is AN diverge. Now, can we say AN diverge? Is that true? You must understand that there's a logic that different, right? Absolute value of AN diverge. Can we say AN diverge? Matthew said no. Okay, I agree with you, right? No. You couldn't say anything. Okay, this is always true, but it didn't mean AN diverge, absolute value of AN diverge, AN diverge. We do not have such kind of statement. Okay, this is not true. They are different, right? Just like apple is fruit, but fruit may not be apple. Do you guys can understand this kind of logic? Okay, so even though we know the original series is not absolutely converge, okay, it's diverge, absolute value of diverge, but we couldn't justify anything for the original series of AN. So even though for this guy, okay, even though you justify, you put the absolute value, find the ratio test, find absolute value diverge, but for the original series, you couldn't get any information. Okay. The reason is this kind of logic I just explained. So ratio test actually for this one fails. Okay. This fails is not ratio equals 1. This fails is logic fail. Okay. I want to know this one is apple or not, but you told me that's not pear. Didn't help, right? I want to know that's apple, but you tell me that's not pear. Okay. Okay, so let me follow the idea from Hadia. Okay. 3 conditions, right? This is alternating series. I'm going to do alternating series test for this guy. Okay, alternating series test number 1. N factorial over 2n, that's bigger than 0, right? Of course, that's of course bigger than 0. Number 2, un, right? Decrease. Number 3, go to 0. Okay, I personally, I will do the second, I will do the third, okay, first. Because this is related to the limit, and the limit, I have so many of tools to do that. To get decreasing, sometimes it's difficult. Okay, so let me do the third one first. Then we're going to do limit n factorial over 2n. Now, how to find the limit for this guy? Any idea? So nobody want to do that L'Hopital's rule? Can we do L'Hopital's rule for this guy? Why not? Yeah, factorial, right, exactly. Yeah, good. We couldn't do L'Hopital's rule. Wow, then this one is hard. Okay, remember why we have done so many questions about factorial. Okay, sometimes it's just like a hot rock. Okay, very big rock. We couldn't do anything for that, and the only thing we can rely on is definition. Yeah, that's the only thing we can do. Okay, I don't know how to do that, but I know the definition. So let me just do the definition. So this one equals to. What is the definition for n factorial? Yeah, it is 1, 2, 3, 4 to the n. Okay, then what's the definition for the bottom 2 to the n? Two, 2, 2, 2, 2, right? Okay, so now tell me the limit. Okay, I give you another chance. Is that really 1? Okay, we get 1. Remember, we have done such kind of example before. I'm going to take a pattern of this, of this, of this, of this, of this. Yes, that's infinity. See? After the 2 over 2, everything is very big. It's a 1.5, 2 times 2 times 3 times 4 times 5. something like this, right? For example, n equals to 300 billion, okay? How big is that? Very, very huge, right? So the limit actually is not equal to 0 as it goes to infinity. So what's the conclusion? Number 3 is fails. Diverge, right, diverge. Okay, diverge. By the divergence test, right? By divergence test. Because this one, okay, this one is not go to 0. This one go to infinity, right? You have infinity of infinity together. Okay, so it's diverge. No, alternating series test also, okay, use the divergence tests. This one fails, alternating series test fails, but also from divergence test is diverge. Okay, that's not a contradiction. Okay, that's the two things can be, one. Okay, A could use B, B could use A, right? They are helpful for each other. All right. Of course, you can say, okay, by alternating series test, it fails. Okay, but how to use alternating series test to justify it fails? The mediate, okay, the process in the middle is using the divergence test. Okay. Is that clear? Frozen again. Okay. Okay, so this is for, that's a very good example because, okay, sometimes when you get the absolute value, absolute divergence, okay, but you couldn't tell anything for the original series. That's a very good example because somebody, okay, there are many people make such kind of mistake. Okay, let me restate. So if this one converge, then this one, then this one, what happened? This one converge. That's the only thing we have. But if this one diverge, then what happens to this one? I know somebody wants to say, okay, that diverge, but what's the truth? We don't know, right? We don't know anything. Okay. This particular example is a good example, but there is another, okay, very easy example for this guy. Okay, this is another example. Let's see. What's this? What's this? Summation of what? 1 over n. So converge or diverge? Diverge. Harmonic series, right? Diverge. But what about this? This one converge or diverge? No, you could tell, okay. Do not justify diverge. Why? Okay, Bailey told me diverge. Hadia told me can't tell. It goes to negative to positive, yes. Yes, I agree with you. It goes to negative to positive, but we have something test. We have some test to justify this guy. What kind of test? What kind of series? Alternating series. Yeah, that's alternating series. We have to rely on the alternating series tests. So now tell me 3 conditions. Number 1. What is that? What's number 1? UN positive. UN is 1 over n positive, right? Number 2. What is number 2? UN decreasing. 1 over n decreasing. Yes. Number 3. What's number 3? UN continuous. Who told you continuous? Go to 0. Okay, see? 1, 2, 3. 3 conditions are satisfied. Then what's the conclusion for this guy? Converge, yes. See? This is a counterexample because, okay, for this series, AN diverge. AN converge, right? Right? See? Is that a good one? Absolute value diverge, but AN converge. This is very, very interesting stuff. Now, did you get that? Any confusions? Okay, so far, you have to understand what I said. Math is logic. Okay, if the logic is true, you'll have to agree with that. Yeah, this is a lot. I agree with you. Yes. Okay, any confusions inside of that? This logic is totally like a apple is fruit, but fruit may not be apple. Okay, apple is fruit, fruit may not be apple. The only thing, okay, I suggest you remember this one. Okay, so A go to the B. A go to the B. Yeah, this is actually the basic logic for middle school. I think if A go to B, not A go to where? Not B? If A go to B, not A go to where? Yeah, no idea. But not B go to where? Not B go to where? Not A, right? Good. You know that, right? It's very basic logic. See, we apply this logic to the stuff. See, this one comparable to what? AN converge. AN converge. Right? This is the A. This is the A. This is the B. Now I'm gonna do the logic, not A. AN diverge means what? This is not A, right? Not A. Means what? Means nothing. See? Second logic. Okay, now let's see not B. What is not B? What is not B? The third one, what is not B? Not B means AN diverge, right? Now let's see, what about not B means not A. What is not A? This one diverge, right? Right? Of course, AN diverge, absolute value diverge, because absolute value is bigger than that. Okay, so this is comparable to this one. So what are we studying right now? We're studying the high school logic, right? We are repeatedly, okay, using the high school logic. Pear is fruit. No, apple is fruit, but fruit may not be apple. Exactly this kind of logic. So what is math? Math is laugh. Okay. Is that clear? Do you like that? Frozen. Okay, come on, guys, you are frozen. I'm frozen. Okay. Okay. So let me continue. All right. Now we're gonna study some new stuff today. Okay. So we're gonna study something like so-called power series. Okay. So power series, what that means? From the name, okay, we know, okay, everything should be about power, right? Everything should be power. So yes, this one is formed like this: x to the n. Okay, what is x? X is a variable. That's a power function, right? X to the n is power function, right? That's not power. That's power function. Okay, 1 to the 2, 2 to the 3, 3 to the 4. That's a power, right? That's a power. But the power function means x to the n, right? It has to be a x, otherwise it cannot be called a function, right? So x to the n. Okay, but if we write n from 0 to infinity, okay, this one gonna be 1 plus x squared plus x cubed. Okay, to make it more general, okay, because every coefficient should be 1, okay, may not be 1. So to make it more general, so we put Cn here. So this is called power series. Power series. So let me make this everything up, right? Every terms. So the first term is gonna be C0, x to the 0, right? Second term, C1, x to the 1. Third term, C2, x to the 2. C3, x to the 3. C4, x to the 4. Just keep going. Okay, and what is x to the 0? 1, right? So this first term is going to be always a constant. And second term is the linear polynomial. Third term is quadratic. Okay, fourth term, cubic. Oh, 4, right? Quartic. Fifth order. Keep going, right? What's that? That's power function, okay? Okay, so sometimes to make it more general, okay, not every term should be x to the n. So another kind of form of power series is going to be this, Cn x minus a to the n. Okay. So if you write everything up, you can do the same thing. It's going to be, what's the first term? C0 x minus a to the zeros. So that's 1, right? C1, C2, C3, right? So this one is a particular, okay, it's a special, okay, power series 1a equal to 0, okay? Sometimes you're going to meet the first form, okay, first form. Sometimes you're going to meet the second form, okay? All of those are power series. Is that clear? Okay, so first we have to know what is power series. Constant, Cn is constant. This constant means, okay, this constant means is not related to, just guess, not related to what? To x, okay, to x. Cn is not related to x, but Cn of course related to n, right? Otherwise we wouldn't call Cn. So that may change with respect to the n, okay, but that's not included x. Okay, so let's start our first example. This example is very, very easy. So what is that? Just this, x to the n. Okay, that's our first power series. Now let's see. Okay, if I write everything up, okay, it's gonna be 1 plus x squared, x cubed, and keep going to the infinity terms, right? Okay. This is a function with respect to x. X is a variable, so that's a function. Okay, if that's a function, then let's see. I want to see what is f of a function f of x. I want to see what is function of f1/2, f1/3, f1/4, and I also want to know what is f1, f2, f3, f4, right? I want to know the value, okay, respect to the different value of x. So this is what I want. Now let's see. Okay, what is the x equals to 1/2? Then what is the power series? It's going to be 1 plus 1/2 plus 1/2 to the square plus 1/2 to the cube. Keep going. Now tell me, what is that? What is that? Geometric series, yes. Geometric series. And converge or diverge? Converge, why? Yeah, ratio equals 1/2, yes. Okay, so this one I found, yeah, that's the famous geometric series. Okay, if it converge, and also we can find the value of this series, right? Do you still remember what's the value for that? I can find the value of the series. There's a formulation for that. Remember A plus AR? I have done this many times. If R less than 1, what's that equals to? Fraction, right? What's the top? What's the bottom? 1 minus what? Remember? Yeah, 1 minus R. And what's the top? A, yes. Okay, don't forget that. This is geometric series, right? This is geometric series. Okay, so just apply that formulation. So what's the result for this guy? That equals to 1 minus 1 over 2 of 1, right? Everybody follow me? Okay, good. So, okay, if I record this guy to be fx, now I find, from this example, I find f1 half equals to 1 over 1 minus 1 half, right? Now, okay, remember that. Okay, let me keep going. How about x equals to 1/3? Okay, how about x equals to 1/3? Then the series will be 1 plus 1/3, 1 plus 1 over 1/3 square. Okay, and this series is also, what series? It's also geometric, and it is also converge, and you also can tell what is the result for that. Is that 1 over 1 minus 1/3? Yes, good. Okay, so I got f1/3 equals to 1 over 1 minus 1/3, right? No, I'm just keep going. Okay, how about x equals 1/4? Okay, I'm keep going. So what's the result over here? Any change? The bottom will be 1 minus 1 over 4. Yes. Okay, so what I got? I got 1 over 4 equals to 1 over 1 minus 1 over 4. Okay, how about 1/5? Just like a worker, right? How about 1/5? What's the difference right here? 1 over 5, right? Okay, so see, from those examples, from those numbers, I almost could have a conjecture. And the conjecture is what? F of x is simply equals to what? Yeah. 1 over 1 minus x, right? Did you see that? See? This is 1 over 5, 1 over 5, 1 over 5, 1 over 4, 1 over 4, 1 over 2, 1 over 2, 1 over 3, 1 over 3. So I have a conjecture. This is my conjecture, okay? Oh, I'm not sure which one. My spelling is correct? This is my guess. Okay, then if it is true, I'm gonna erase this one, all right? If it is true, if this is true, I can find f of 2, right? Now let's see, what is f of 2? If this is true, if this conjecture is true, okay, that equals to 1 over 1 minus 2. What's the result for that? -1. Oh, unbelievable. F of 2 equals to negative. But what is f of 2? F of 2, by definition, the series should be equals to summation of 2 to the n. It should be equals to 1 plus 2, 1 plus 2 to the square, 1 plus 2 to the cube. This one equals to 1, -1? How come? That's not true, right? Then where's the problem? This is geometric. See, this is my conjecture. From my conjecture, I find f of 2 equals to -1. That's not reasonable. That's not reasonable. So the only mistake will be my conjecture would be, this conjecture would be wrong, right? This conjecture is wrong. But remember what I did? I did so many 1 over 2, 1 over 3, 1 over 4, 1 over 5, right? I did so many of stuff. It's true, right? So that means this conjecture is conditionally correct. Then what condition it is? Yes, exactly, good. Okay, f of x equals to 1 over 1 minus x. It must be x less than 1. Okay, if that's less than 1, why? Why this is the condition? Because only one x less than 1, the geometric series converge, right? Okay, so only one less x less than 1, the geometric series converge. Which means, in other words, okay, so let me repeat. In other words, okay, this one, okay, this one equals to 1 over x if x less than 1. This one equals to what? 1x bigger than 1. What should I feel here? 1x bigger than 1. What happens for this series? Diverge. Yes, this one diverge. Okay. Interesting, right? And this also means the following easy statements. X less than 1 is the domain making series of this converge. Do you agree? I'm just trying to restating my word, okay? Do you agree? X less than 1 is the domain making the series converge, right? Of course, right? Okay. In other words, see, I'm trying to restating the same thing, okay? In other words, that's the last sentence of this class. In other words, x less than 1 can be called as what? Convergence domain. Do you agree? Very straightforward, right? Okay, so the typical question, okay, in other words, I'm saying too many times of in other words, right? So in other words, the central topic for geometry, for a power series is what? Find what? Just guess. Convergence domain, right? Find the convergence domain. You will see a lot of questions. Find the convergence domain for this power series. Find the convergence domain for the other series. Find the convergence domain for this series. What is convergence domain? From this example, we are clear, right? That's some part of the region, okay, make the series converge. Okay, outside of this region, the series diverge. Is that clear? That's the end of this class. Any questions? You guys frozen? Any questions? Okay. Yeah, we will decide the review next time, because we can put forward one day for the midterm. Is fine, no problem. Yes, yes, we will find the details how to find the convergence domain next time. Okay. Yeah, again, yeah, same thing, similar. 5 to 7 questions. Okay, same form, same formats. Okay. Blackboard. Okay, uploading, scan to PDF. Everything is the same, right? Okay, no questions. I will let you guys go. See you. Goodbye.